Hello everyone. In today's video, I am going to design a real-time Simulink model that demonstrates regenerative braking and battery management using nickel-metal hydride battery, that is the NiMH battery. Okay, so here you can see the NiMH battery specifications, that 200 volt 6.5 ampere hour. Okay, so here you can see this is the description. Initially the battery is connected to a constant load of 50 amperes. Then the DC machine is connected in parallel with the load and operates at no load torque. When the state of charge of the battery goes under 40%, a negative load torque of 200 Newton meter is applied to the machine, so it acts as a generator to recharge the battery. When the SOC goes over 80%, the load torque is removed, so only the battery supplies the 50 ampere load. Okay, so this is just like a regenerative braking. Okay, when the battery SOC is below 40%, we are using the negative torque so that it acts as a generator and battery are getting charged. So during this simulation, we will observe and display the battery voltage, state of charge, motor speed and motor current. So here you can see the DC machine specifications. So here you can see this is the armature resistance as well as the inductance. All these values are given and these particular parameters we are using during the simulations. So if you are interested in EV systems, battery modeling or regenerative braking simulations in Simulink, this video is perfect for you. Let's go to the Simulink environment. So here is the Simulink interface. So first of all, I am taking the battery. So add to this. Just double click on it. So this is the type of the lithium ion battery. So basically we have to choose nickel metal hydride, and here you can see the specification is nominal voltage is 200 and the rated capacity is 6.5 ampere hour. Okay, so here I am taking the initial state of charge 100% and just apply it. Next I have to take 50 ampere constant load current source. So you have to just search controlled current. So here you can see this is the control current source. So just I am rotating and just connecting to the battery. And constant current source is value is 50 ampere, so that's why I have to take the constant block. Just search on it, constant. So here you can see, just add to this and its value is 50. Okay, now we have to connect the DC machines. So just go to the library and search DC machines. So here you can see DC machine. So the DC machine is connected in parallel with the load. So I am connecting the ammeter, this one and this one. Okay, it is connected. Now we have to connect it the field winding. So here now field winding is connected. Now double click on it, DC machines, and here you can see I already take the preset value. Model is no, mechanical input torque and the field type wound motor. Now here I have to input the parameters. I already share you the parameters. So armature resistance, here I am taking 0.4832 and LA I am taking 0.006763, and for the field resistance and inductance, for that I am taking 84.91, and for it is 13.39. Field armature mutual inductance I am taking 0.7096. Total moment inertia J we consider 0.2053, as well as the viscous coefficient 0.007032. Okay, and rest of are considered as a initial speed 0, initial field current 0. Okay. Okay, now the model is almost completed. So now I have to take the battery SOC. For that, you have to take bus selector. You already know how to take, so just click on add one. So this is the bus selector. So double click on it, remove. Here I am consider only the voltage and SOC. You can also choose the three signals also, like SOC, current and voltage also, but here I am only consider the voltage as well as the SOC. Okay, now we have to take the conditions. So what are the conditions? That if the SOC is below 40%, then we have to apply a negative torque of 200 Newton meter, so that it acts as a generator and the battery got charges. Okay, and when the SOC is over 80%, the load is removed. It is load is removed, so only the battery supplies the 50 ampere load. So this will be the ease. Okay, so for that particular condition, here I am using the relay block. So here you can see, just search on it, relay block. Here you can see this is the relay. Okay, so in the relay I am taking the input as a SOC. So for that, here I am using SOC means in percentage. So here we are getting original value, so that's why I am taking the gain block, so I can divide. So this is the SOC, and percentage means 40%, 80%. So in normal value 40% means 0.4. So that's why I am dividing this SOC as a percentage value, that is the 1 by 100. Okay, so I am giving to this, and this is directly connected to the load torque. Okay, so this TL is nothing but the torque. So double click on it. So here you can see I am taking the switch on point is when the SOC is 80%, means 0.8. What happen output, it will be the 0. When the switch off means when the switch is 0.4, the output will be the minus 200. Its meaning is when the SOC is 80%, the the torque will be the 0. When the SOC is 40%, that time the torque will be the minus 200 Newton meter. Okay, just I am applying. Now I have to take the scope. So from these DC machines we have to take the signals. So double click on it. So here you can see lot of parameters are there, speed, armature current, field current, electrical torque, but here I am only taking the speed as well as the armature current. So here you can see this is the speed and the armature current. You can also take the all the force option, and you can see their output. Now I have to take the scope block, to see the output. So I am taking the scope. So double click on it, as it is the 4 input, so I am taking the 4 input. Okay, so just apply. So in the first connection I am giving the voltage, second one is the SOC, third one is the speed, and here you can see this is the armature current. Now the runtime is considered as a 1000 second. So just run this button. Okay, I already forgot. So I have to take the power GUI. So double click on it. So here you can see the waveform. This is the voltage, this is the SOC, this is the speed, as well as this is the armature current. So at t equal to 0 second, what happened? The DC machine is started with the battery power, and the speed is increases to 120 almost. This is 120 radian per second. The battery is also discharged by a constant DC load of 50 ampere. At here you can see it almost, I think this is the 300 and this is the 280 second. The SOC drops under 40%. A mechanical torque, that is the minus 200 newton meter, is applied to the machines so that it acts as a generator and the provide a current of 100. So here you can see this is the, here you can see this is the 100 ampere current. Okay, so here you can see almost 560 or 80. The SOC is 80%. That type the minus 200 newton meter torque is removed and this load is connected, that is the minus 50. Okay, so here you can see, and this process is continuous. So this is very simple process. Just you have to remember this portion, that is the relay, how when you have to put the switching option and when you have to put that negative torque so that it acts as a generator. So thank you.